Hi guys and welcome. In this video we're going to learn about matrices. Topics covered will be matrices, addition, subtraction, multiplication and inverses, determinants, Cramer's rule for solving equations. In determinants we will be focusing on 2 by 2 and 3 by 3 determinants. Why we use determinants? Determinants are important because we use it to solve equations, right? So let us get straight into matrices. So first thing what we learn about is the order of the matrix. So what's a matrix? We always say rows and columns, right? So this is basically the order of the matrix, how many rows and how many columns. So it's not R times C, it's R by C. So if we looking at the order of the matrix A, or order or dimension, so matrix, the first matrix has 2 rows and 3 columns, so this is 2 by 3. The second matrix in B has 1, 2, 3 rows and 2 columns, so it's 3 by 2. And the third one has 3 rows and 4 columns, so that's 3 by 4. That's the size of the matrix, or the order of the matrix, or the dimension of the matrix. Moving on to the next one, matrix elements. Example, when we say A31, what's the value of A31? Each of these entries in the matrix is called an element. So A31 means go to the third row and first column value. So third row, row 1, row 2, row 3, and first column value is -1. So what's A31? -1. What's A23? A23 will be, that's A31, A23 will be second row, third column. Second row, third column, that's also -1. And A22, A22 will be row 2, second column, so that will be 3. Okay, I hope you guys understood that. Moving on to the next part, which is matrix equivalence. What is matrix equivalence? We have an equivalent matrix 1, 2, 3, 4 entries, which is 2 by 2, and this is also 2 by 2. Now we want to solve for x and y, so we can see this entry for x is by 2x minus 3, and this entry is -11. So this is A11 and this is also A11. So you need to equate the elements. So 2x minus 3 is equal to -11. 2x is equal to, taking the -3 over, you get -11 plus 3, which is -8. Therefore x is now equal to -4 by dividing by 2 both sides. Now solving for y, we have, how do we solve for y? We have -2 is equal to 6y minus 14. So -2 is equal to 6y minus 14. Taking the -14 over, -2 plus 14 is 12. So 6y is equal to 12. Therefore y is equal to 2 by dividing by 6 both sides. So I hope you understood this. Next one, we want to solve for xy. That's pretty simple because the location of x is there and there. So x is equal to 6. Okay, and y is equal to, the location of y is in the row 1 last value, so y is equal to 2. Y is equal to 2. Simple. Moving on to scalar multiplication. Find ka if k is -3, a is equal to -2, a is equal to this matrix 2 by 2. So ka will be equal to, you're taking -3 inside this matrix. So if you take -3 multiply by -2, you have to multiply -3 into every single element, because -3 is kind of like factored out. So you will get 6. -3 times 1 is -3. -3 times -1 is 3. -3 times 3 is -9. I hope you understood that. Let's look at the order or dimension of the matrix again. If A and B are two matrices of dimension 5 by 3, then the order of matrix A minus B is, now remember you can only add and subtract matrices of the same size. Add or subtract same size. You can only add and subtract same size matrix, same size. So if you got matrix A, which is matrix A and B are dimensions 5 by 3, then what's the size or the order of the matrix A minus B? It's also 5 by 3, because you can only add and subtract same size. If matrix A is 2 by 3, now what's the rule for multiplication of matrices? That's what we need to check. For multiplying matrices, the inside entries needs to be the same. So remember, for multiplication, that's the only difficult part, right? For multiplication of matrices, example, if you got matrix A and multiplying by matrix B, so if you got R by C, it has to be C by, let's just say, another value like B, because the inside is the same. Look at the inside dimension, C and C, that cancels out, and the resulting will be R by B, R times B. Right, so this is R times B. That's what you do for matrix multiplication. If the inside entry is not the same, right, if these are not equal, then that matrix is impossible. So if A is 2 by 3 and B is 3 by 5, you can see 2 by 3 and 3 by 5 is followed by a 3. The inside is the same, so the resulting matrix AB will be 2 by 5. So this is 2 by 5. Next one. If A is 2 by 3 and B is 3 by 5, then the order of the matrix BA. What is BA? To find BA, what's the size of B? B is 3 by 5, right? And A is 2 by 3. Right, so what you notice is that inside is not the same. So remember, they're not equal. So what's then the order of the matrix BA is not possible. Not possible. Right, so there is no answer for that. There is no order. So not possible or no order, because 5 and 2 are not the same. If the dimension of matrix AB is 5 by 8, now they're telling us AB is 5 by 8, okay? So you had A times B. Right, so remember, you had matrix A and you're multiplying it by matrix B. So, and the order of matrix A is 5 by 6. So if this is 5 by 6, it has to be followed by 6 by what? Because remember, the 5 is there, right? It has to be 6 by 8, and 8 is here. Look at that, right? So we know the 6's cancel out. That's how you solve this. So then the order of the matrix B is 6 by 8. There's it here, 6 by 8. I hope you understood all this. Moving on to the next one, matrix addition and subtraction. As I told you, to add and subtract matrices, only same size. So let's do this one here. We got 3 times 3 is 9, 3 times 5 is 15, 3 times 2 is 6, 3 times negative 3 is negative 9, minus 2 times 3, so you can just add it up like this. Minus 2 times 3 is negative 6, minus 2 times 5 is negative 10, minus 2 times 2 is negative 4, minus 2 times negative 3 is positive 6, alright? Now we can just add both. 9 minus 6 is 3, 15 minus 10 is 5, 6 minus 4 is 2, minus 9 plus 6 is negative 3. So that's the answer for this. 3, 5, 2 and negative 3. Next one, we want to evaluate the second one. Let's put the negative inside. So in other words, it's negative 1 outside. Negative and negative makes positive, so that's 1. That's negative 2. This is 0. Negative 0 is 0. Negative negative 3 is 3. Plus, what's 2 times 1? 2. 2 times 3 is 6, 2 times negative 2 is negative 4, 2 times negative 2 is negative 4 again, right? Now add it all up. 1 plus 2 is 3, minus 2 plus 6 is 4, 0 minus 4 is minus 4, 3 minus 4 is minus 1. So that's my answer for this problem, evaluating the matrices. Moving on to the next one. Matrix equations. Now how do you multiply this out? Solving matrix equation. So you're going to take row 1 multiplied by column 1, row 2, and it's going to be equal to negative 3. So what we have is 1 times x is x. Let's solve the first one. So if I'm solving the first one, x minus 1 times y is minus y is equal to negative 3. Second equation, 2 times x is 2x, 1 times y is y equals negative 6. I think we can just add both the equation and solve for x and y. That's out. 3x is equal to negative 9, so x is equal to negative 3. So what's the answer for x? Negative 3. So what's the value for y? If I put negative 3 inside here and take it over, I'll get 0. So y is equal to 0. Y is 0 and x is negative 3. I hope you understood that, guys. Next one, same problem. Find the value of x and y. This is written in the form of a matrix equation. So 2x plus 3y. This is 2x plus 3y is equal to 5. 4 times x is 4x. Minus 1 times y is minus y is equal to 1. So I can take equation 1 and multiply it by 2 because I want the same values here, or multiply by negative 2. Multiply by negative 2. So negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6y. Negative 2 times 5 is negative 10. And look at the second equation. 4x minus y is equal to 1. If I add up both the equation, 0, right? Negative 7y is equal to 11. So y is equal to negative 11 over 7 by dividing by negative 7 both sides. Now to solve for y, what is y? Basically y, you can solve from the second equation, it's easier. You can take the negative y over. Y is equal to 4x minus 1. Bring the 1 over. And what is the value for y? Negative 11 over 7. We solve for y, we need to solve for x. 1 second. To solve for x, it will be easier to, it will be easier to solve for, okay, let's just solve for x here. 4x is equal to 1 plus y. So 4x is equal to 1. What is y? Minus 11 over 7. Right? So we're going to take the first part and multiply by 7 over 7. Multiply by 7, 1 times 7, 1 over 1 is 1. So 7 minus 11 will give me minus 4 over 7. Right? Now I need to divide by 4. Dividing by 4 is multiplying by a quarter. So 4x times quarter equals minus 4 over 7 times quarter. Right? Now solving this, we can see the 4 and the 4 cancels out. So I've got x is equal to, and the 4 and the 4 cancel out, that's negative 1 over 7. So what's our answer for x comma y? It is basically negative 1 over 7 and negative 11 over 7. I hope you understood that. That's the answer for x and y. Now matrix multiplication. How do I do matrix multiplication? In the first one I've got 1, 2, 3. I got 1 row and 3 columns. I got 2 rows and 3 columns. 1 row and 3 columns, and I've got 3 rows and 2 columns. 3 rows and 2 columns. 3 rows and 2 columns. So I can see the insides cancel out, 3 and 3, and I will get a 1 by 2. What is 1 by 2? 1 by 2 is 1 row and 2 columns. So I need a value here and a value there. Very simple. We take the first row and multiply by the first column. It's always row times column. It's always row times column for matrix multiplication. So I will take first row, multiply by the first column. So we can do all the calculations in the side. 4 times 2 is 8. 0 times negative 3 is 0. Minus 2 times 0 is 0. So that's just 8. So I put 8 here. Then 4 times negative 1 is negative 4. 0 times 0 is 0. Negative 2 times 4 is negative 8. Add up everything, I get negative 12. So 8 and negative 12, those are your two entries. So what is 8 and negative 12? The product AB. Basically I just worked out A times B here. Alright, so quite simple. Moving on to the next one. I want to find A squared. To find A squared, if A equals this, so we're going to say A is equal to, I'm just going to copy this twice and paste it, right? A squared will be A times A, right? A squared is A times A, and remember I have a 2 by 2 multiplied by 2 by 2. I have 2 by 2 multiplied by 2 by 2. So the insides cancel out and I have 2 by 2. So I have the exact same matrix, 2 by 2, right? Same size of the matrix. Now we're going to take row 1 times column 1. So let's do that. 3 times 3 is 9. 5 times minus 1 is minus 5. Add up both. I get 9 minus 5, which is 4. Right? Next one, take row 1 times column 2. 3 times 5 is 15. 5 times minus 2 is minus 10. Add both, I get 5. I'll put 5 here. Now I'm done with row 1. There's it here. Now I'm dealing with row 2. Row 2 I have here minus 1, minus 2. Right? So you see minus 1 times 3. Row 2 times column 1. Row 2 times column 2. So minus 1 times 3 is minus 3. Minus 1 times minus 1 is 1. 1 second. Minus 1 times 3 is minus 3. Minus 2 times minus 1 is 2. So I get negative 1. That's my answer. And the last one, minus 1 times 5 is minus 5. Minus 2 times minus 2 is 4. Add up both, I get negative 1 again. And that's my answer. A squared is 4, 5, negative 1, negative 1. I hope you guys understood that. Now, to find the inverse of the matrix, this is what we do. If we have a matrix A, which is A, B, C, D, to find the A inverse, we're going to remember this V, very important. Right? This is a V, right? So, and you're going to put an arrow here to swap. So first what we're going to do is 1 over D. What is D? A times D, the determinant. A times D is AD minus B times C. This is called the determinant or the denominator. Now if the denominator is 0, there is no inverse because you can't divide by 0. And the next one is switching these two. D goes up, A comes down, and negative. The other positive diagonal takes negative. Right? That's how you find the inverse. Now remember, if denominator is 0, if D is equal to 0, then no inverse, because you can't take 1 divided by 0. It's undefined. So that's the reason why we say there is no inverse. Now let's find the inverse of this matrix. So first we're going to find the determinant. So we're going to say A inverse, this is matrix A. 1 times minus 4, so 1 times minus 4 is minus 4, minus 1 times 2 is minus 2, right? Now we're going to switch these two around, minus 4 and 1, and this diagonal will take negative sign, opposite sign, so 1 and minus 2. Now what I have here is 1 over negative 2, because minus 4 plus 2, right? And this one is negative 4, negative 2, 1, 1. Now remember what we were doing before, we need to take the negative half inside. So basically you're taking each of these entries and multiplying by negative half, or you're dividing it by negative 2. So negative 4 divided by negative 2 is 2, negative 2 divided by negative 2 is 1, minus half times 1 is minus half, 1 times minus half is also minus half. Or you can take 1 divided by negative 2 is negative 1 over 2, 1 divided by negative 2 is negative 1 over 2. So that's the inverse of this matrix. Why we use inverses? We use inverses to solve matrix equations, or we can solve simultaneous equations using matrices. Example. Remember we have a matrix equation here, like what I gave you here. You remember the answer? Let's look at this one, right? Question 7. Question 7a. If I go back, right? Question 7a. Let's resolve this using matrices, right? Matrix inverse. find the value of x and y. We can use an inverse to solve for x and y. Remember, x was -3, y was 0. So I will come to the same answer over here. If you don't understand what's the purpose of finding the inverse. Right, so note, this is using inverses, right? So what you just have over here is ax is equal to b. So x is equal to a inverse b. I can find the inverse of 1, -1, 2 and 1, right, and solve this matrix equation. Remember, this is b. So let's find, remember, a is 1, -1, 2 and 1. So to find the inverse, 1 times 1 is 1, right? Minus 2 is +2 into. Switch these two around, 1 and 1, opposite sign, -2 and 1. Now if I take this 1/3 inside, I will get 1/3, 1/3, minus 2/3 and 1/3. That's my inverse. So put your inverse here. I'm showing you a way we can apply this inverses to solve matrix equation. Remember what was x? This is x and that's y. What's A inverse? 1/3, 1/3, minus 2/3 and 1/3. What's matrix B? -3 and -6. Now solve. Row 1 times column 1. So you should get an answer. X, y. What's row 1? 1/3 times -3. That's -1. 1/3 times -6. That's -2. Add up both, you get -3. Next one, -2/3 times -3. That's -6/3. That's -2. And 1/3 times -6. That's +2. And that's -2. That's 0. So can you see? X equals -3, y equals 0. And that's the same answer we had before. Okay? X equals -3, y equals 0. So I just showed you where inverses are applied in the real world in solving equations. Find the inverse of the matrix. You can find the inverse of this matrix. So A inverse is equal to 2 times -2 is -4, minus 4 times -1 is again -4. So wait a minute, what do we have here? We got 0 in the denominator, so right here A inverse D equals 0. Okay, so A inverse does not exist, so we can't really find, because I got -4 plus 4, I got 0 in the denominator. So because I got 0 in the denominator, A inverse does not exist. What are you going to do? You're going to say 1 over 0. Even if you try to switch these two around, it's not going to be helpful because it doesn't exist. Does not exist, right? Now what you got? You got 1 over 0. What are you going to multiply into? You can't multiply into anything because it does not exist. The denominator is 0. Be careful, right? So next one is a nice theoretical question. Find y such that the matrix below does not have an inverse. When will the matrix not have an inverse? When the determinant is 0. D is equal to 0. No inverse. That's what we want to find. So what's the value for y, right? So we'll take -5 into y plus 1, subtract 2y and make it equal to 0. Solve this equation. -5y minus 5 minus 2y is equal to 0. Okay? Now solve for y. You got -7y is equal to, take the -5 over -5, right? And then y is equal to 5 over 7. I hope you understood that, because I dropped the negatives on both sides and divided by 7 both sides. So y is equal to 5 over 7. Moving on to the next question. Determinants. How do I find the determinant of a 3 by 3 matrix? Remember, even for this, if the determinant is 0, then the inverse does not exist. Now I want to find the determinant for this, so we say A. Now for determinant we use an absolute value sign. So you're going to take the same matrix and put it here. So you got 1, 3, 2, -3, 2, -3, 1, 3, 1. Right. put your vertical line here, extend the first two columns, 1 and negative 3. Just one of the ways of solving, easy method for solving a 3 by 3 determinant. 3, 2, 2 and negative 3. There are other methods which involves cofactor expansions and stuff which we don't need to know. So we're going to take the down diagonal, right, and minus the up diagonals. Right, so down minus up. Just remember the V. When you draw a V, down first and subtract up. Okay? Down diagonal minus up diagonal. Now, let's work this out. So you got 1 times 2 times 1, that's 2. Minus 3 times 2, that's negative 18. And 1 times 3, that's negative 9. Right? That's the down diagonal, the product sum. Minus. The up diagonal is 2 times 2 times 1, which is 4, minus 9, and that's also minus 9, right? So you got 2 minus 27, which is minus 25, and you got minus 18 plus 4. Minus 18 plus 4 will give me minus 14. Minus 14 is plus 14, right? And minus 25 plus 14 is negative 11. I hope you understood that. So what's the determinant of this? Negative 11. In other words, if you want to write the determinant of A is equal to negative 11. That's how you write it. Determinant. Absolute value means determinant of A. Moving on to the next question. Find the determinant of B. Similar problem. Right, so guys, you know what to do. You're supposed to be using absolute sign. I'm just going to change this. Alright, I'm just going to extend the 2 rows on this side. I have to assume that this is an absolute sign, right? I don't want to rewrite all this now. So what we have here is negative 1, 5, 2, 3, 2, negative 3. Now let's find the determinant. Down diagonal minus up diagonal. This is not lining up. Let's line it up, right? Next one, positive diagonal. Right, so make sure you carry a pencil as well, right? Pen and pencil. Do all this in pencil. So minus 1 times minus 1, that's 1. 1 times 2 is 2. Plus 0. We got negative 15 here. Subtract. What are the other 3 values here? Let's see. Let's move this to the side. Let's write it here. I'm trying to find the determinant of B, okay? By the way, determinant can't be negative, right? You don't take the absolute of negative 11. Determinant is basically I'm finding the determinant of A. I'll put the absolute A here. So I'm finding the determinant of B, absolute B, alright? Determinant of B. Not I shouldn't be reading it as absolute of B, because absolute B means positive value. This vertical line means determinant of B, determinant of A. So up diagonal is 4. That's going to give me 0, and this will give me negative 15 up diagonal. See there? 3 times 5, 15, negative 15. So 2 minus 15 is negative 13. 4 minus 15 is negative 11. So plus 11. That's going to give me negative 2. Yes, and you can see determinant is negative 2. Next one. Now, where do we use these 3 by 3 determinants? Mostly for solving equations like Cramer's rule and stuff. So there's a lot of work to be done here. I want to solve for x, y and z. Now let's solve for x, y and z. I want to solve for x. I'm just going to solve for x and y, substituting into the first equation and then find z. Right, so we're going to find d, the main determinant. The main determinant will be 2 minus 3 minus 2. 1 minus 1, 1. Minus 1, 2 and 2 in the z column, right? And you know what to do, extend the first 2 columns. 2 minus 3 minus 2, 1 minus 1 and 1, right? And let's look at the down diagonal. There's the down diagonals, right? And let's look at the up diagonals, positive diagonals, right? 1 2, 3. Always do this so you don't make mistakes. Right, so I'm trying to solve this now. That's -4, that's -4 again, and that's +3, right? And we need to subtract the up diagonal. That's -2 +4 -6. Now we have -8 + 3, that's -5, and we have negative what do we have? -4, so +4, that's -1. Should we have +4? Oh, -2 -2, that's -4 with a negative, become +4, so -5 + 4 is -1. Perfect. Now find dx. How do I find dx? Take 8 - 11 - 3 and substitute it into the first column, right? So 8 - 11 - 3. Now write the balance. 1 - 1 1 -1 2 2, right? Again 8 - 11 - 3, 1 - 1 1. Now let's find the determinant of this. The determinant of this is 8 times 1 times 2, that's -16, -6, 1 minus, so +11, right? You can check that out by highlighting. There's -3, +16, and -22. So I just need to add up all these. That's -22 + 11, that's -11. -22, this is -22 - 3, that's -25 + 16 is -9. So I'm going to get +9, so that's -2. So what's the answer for x? To solve for x, you're going to say dx over d. Dx is -2 over -1, so x is equal to 2. Perfect. I got an answer for x. Right, now let's find dy. dy, I just want to copy all this, it's much easier. See what I'm doing for dy. Let's put it here. Right, so I need to take this 1 minus 1 and 1 out and copy this here. So I substituted 8 minus 11 and -3 into the second column, right? So 2 minus 3 minus 2 needs to remain there. 2 minus 3 minus 2. And you know what to do? You need to extend the first two columns on the outside. I'm just going to copy and paste. Okay, so I hope you understood that. See? The first two columns out. So what's different from this D to the original D? All I've done is I've replaced the Y column with these values. So because I want to solve for Y, to solve for Y it's going to be dy over D. Right? Now it's no more dx, it's dy. Now let's find. So that's -44. 8 minus 2 minus 2, that's -32. See, the 8 times 2 is 16 times minus 2 is -32. So you got -1 minus 3 minus 3, that's -9, 3 negatives, right? Subtract. That's -22, right? That's 4 times -3 is -12, and this will give us 2 times -3 is -6 times 8 is -48, right? -44, -32, -9. Have a lot of numbers here. Right, let's see. -44, -32 is 4 and 2, that's 6, 76. -76, -85, because I'm minusing 9. -85. Yeah. I don't know whether, yeah, it should be added to 22 and 48. 22 and 48. 2 goes there, so it's going to give me 70, 82, -82, so +82. So dy is -3. So y is equal to dy over d. That's negative 3 over negative 1. So what's y equals to? 3. So I got x as 2, y is 3. Now to find z, you need to take 8 minus 11 minus 3 and substitute into this column. Otherwise you don't need to do that, because you see, we know what x and y is. We can just substitute into z and solve. So 2x plus y minus z equals 8. I don't need to go and solve. So what I have here is 2x plus y minus z is equal to 8. 2x plus y minus z is equal to 8. Right. Now solve for z. So z is equal to 2x, 2 times 2. What's y? Plus 3. Take the 8 over, minus 8 is equal to z. So z is equal to 2 times 2 is 4, 4 plus 3 is 7, 7 minus 8. So z is equal to negative 1. Right, that's how I solve for z. So I got 2, 3, negative 1, x, y, z, my answer. X, y, z. I got 2, 3 and negative 1. Now look at part B. I only want to solve for z here. To solve for z, very simple. You're going to find d first. You're going to find the main determinant, 1, 2, 3. Then you're going to go 1 minus 1, 4. 1, 3 minus 1. Right? And copy the first two columns on the outside. Just copy it here. Right, and now you're going to find the main determinant. Right, you don't have to keep on doing that if you have mastered determinants, right? You don't have to keep on highlighting. Let's calculate. That's 1, that's 9, 1 times 2 times 4, that's plus 8, right? Subtract, negative 3, plus 12, minus 2, 9, that's 10, 18, minus 12 minus 5, is that right? 12 minus 5 is 7, 7 on the inside, so negative 7, and 18 minus 7 is 11, negative 1, 9, 8, negative 3, 12, 2. So that should be fine. Just double check your answer. If you have any queries, don't forget to comment in the comment section below. Right, let's see. I have 11 as my answer. Now to find dz, determinant of z, right? I have 1, 2, 3, 1 minus 1, 4, and substitute 6, 14 and 2 into the z column. So this one will be still the same, 1, 1, 2 minus 1, 3 and 4. Let's multiply everything out. Right, and then upper diagonal. Right, so let's see. Negative 2, 14 times 3 is 42. And the last one, 6 times 2 times 4, that's 8 times 4, that's 48. 6 times 2 is 12, times 4 is 48. Subtract, up diagonal, negative 18, 14, 28, 56, that's plus 56, plus 4. Right, let's see. That's 40 and 48, that's 88, minus 56 and 4 will give me 60, that's going to give me 42. One second, let's see, should give me 60 minus 18, 60 minus 18 is 42, so negative 42. Yeah, so that's going to give me 46. So z will be dz over d. dz is 46 over 11. That's it, that's the answer, 46 out of 11. I can't really simplify this. Right, find the area of the triangle. We want to find the area of the triangle, we use a formula using matrices. Remember, the area is the absolute value, you have to take the positive area, right? So area is half into coordinates with 1 1 1, right? And what are the coordinates? 0 0, the next coordinate -1 and 4. You can put the coordinates in any order, and 2 and 6. Now this is finding the determinant, so extend those two on the outside. 0 0, -1 and 4, 2 and 6. Now let's see. Right, coming down and then up, and remember there's still a half outside. And the nice thing is that because you got so many zeros, it will work out nicely, right? So half, right? So 0 plus 0, -6, subtract, that's 0, that's 0, 1 times -1 times 6, that's -6. Yes, 2 4 and 1, that's 8 products, plus 0 plus 0. Now I've got half. We're going to find the area of this triangle here, right? Into -6 -8. So half into -14 is -7. So area is equal to absolute value of -7, which is 7 square units. Right, so I hope you guys understood that. Remember, the area is always the absolute value. Now next one, find the area of the triangle. Last question, find the area of the triangle with vertices. These are the vertices. Now to find the area of this triangle is quite simple because it's like a straight triangle, horizontal. So from -2 to 2, you can use geometry to solve. So area is equal to half. What's the base? Base is from -2 to 2 is 4. And what's the height? Height is from -1 to 4, which is 5. 5 times 4 is 20. Half of 20 is 10 square units. Right, we can also, or you can use matrices to solve. A equals half, A equals half. Let's put the values. Let's draw a line here. Okay, right, let's put the coordinate values. Right, so what are the coordinate values? We got -2 -1. Don't forget to put 1 1 1 at the end. Next one is 2 and -1, and 0 and 4. Nice, we have 0. So -2 to 0, -1 -1 and 4. Remember, I put them in any order or order preference, whichever way you like, right? And then up diagonal, should get the same answer, 10, alright? Now let's solve. Half into, put the, make sure you use double brackets and stuff. You don't have to use a square bracket, you can use a round bracket. So -2 times -1 is 2. That's 0. That's plus 8, right? Subtract 0, -8, and this is what, 1 times 2 times -1, that's -2, right? So I've got half into 2 plus 8 is 10, minus minus 10, so plus 10. Nice, so you already got 10 square units. No need to take absolute value, right? Square units. So sometimes the geometry works out perfect, and with funny triangles like this, just try to use the area formula, right? I hope you guys understood this entire matrices, and don't forget to leave comments in the comment section below. Thank you.